Hello, my name is Tyler Harvey, and I will be doing an instructional video on the question provided. So the question here says, a contestant on a game show spins a wheel that is located on a plane perpendicular to the floor. He grabs the only red peg on the circumference of the wheel, which is 1.5 meters above the floor, and pushes it downward. The red peg reaches a minimum height of 0.25 meters above the floor, and reaches a max height of 2.75 meters above the floor. Now it is asking us to sketch two cycles of the graph that represents the height of the peg above the floor as a function of the total distance moved. Then determine the equation of the sine function that describes the graph. So automatically I can tell that this is a sinusoidal question because it gives us a maximum height and it gives us a minimum height, and those two heights are being repeated at the same time. And so, I'm just going to go back to this question here and highlight some key points. So, the first key point here is that when he grabs the red peg is 1.5 meters above the floor, and the red peg is also being pushed downward. The other key points here is that the minimum height of the peg is 0.25 meters. And the peg also reaches a maximum height of 2.75 meters. And now, what the other key point is what is asking us to do. So it is asking us to determine the equation of the distance moved by the graph. So, right here. Okay, and so I just have a brief diagram right here of what the red peg looks like. So right here you have the red peg, and so this entire thing right here is the wheel, and so the minimum value of the wheel right here is 0.25 meters above the floor, and when the peg starts off it is 1.5 meters above the floor, and the maximum height of the wheel right here is 2.75 meters above the floor. And when he pushes the red peg, he pushes it downward. So this wheel will be moving in a clockwise rotation. And so, since this question is asking us to find the total distance of the graph of the wheel moved, the only way that we could calculate the total distance of one rotation is to calculate the circumference of this wheel right here. And so in order to calculate the circumference, we need the radius. And just write down here how to calculate the circumference. So it's 2 multiplied by pi multiplied by the radius of the circle. So in order to calculate the radius of the circle, we can also find it as the maximum height minus the minimum height divided by 2. And so the maximum height and the minimum height are both given to us. So we have the max height, which is 2.75 meters, minus the minimum height, which we have right here, which is 0.25 meters. And we do all of this divided by 2. And so what this gives us is that the radius of the circle is 1.25 meters. And now go back and plug the radius, into the equation to calculate the circumference of the circle. So we go back here, circumference equals 2 multiplied by pi multiplied by the radius. So to sketch this out, we have 2 times pi multiplied by 1.25. And what this gives us is 7.854 meters. And so in order to complete one full rotation, the red peg must move a total distance of 7.854 meters. And now this can also be written as 5 pi over 2 if you want to look at it in radians. And so now we will go back and calculate, or just sketch out our graph. Now, since we know that the total distance moved in one full rotation is 7.854 meters, then that is the amount of meters that the peg must move in order to complete one full cycle. So we'll sketch out our graph here as so. And since the period of this graph is 7.854 meters, we write it out right here. And now since it is asking us to complete 2 cycles, we will find that we must multiply this by 2 in order to give us 2 full rotations. And what this gives us is 15.71 meters. All right, so we have our 2 cycles right there. Now, using a different pen here, we must put in some more points. And so 7.854 divided by 2 is 3.92. And then half of that is 1.96. Then we will put this value right here, which is 5.88. And now, putting in some more points, we have 9.8, then 11.76, and our last point will be 13.72. Now we'll also label the heights of the graph. So we have our minimum height here of 0.25 meters. We have the height that the peg starts off at, which is 1.5. And then we label our maximum height all the way up here, which is 2.75 meters. Okay. Now we will begin to label these points. So we know that the red peg starts off at 1.75 meters. And in order to get back to that original height, it must move a total distance of 7.854 meters. Now we begin to label the rest of these points. And because, since in the equation, or in the question, it says that the peg has been pushed downward. And so this is key because this is what gives us the shape of our graph right here. If it says that it would be pushed upward, we would be getting a graph that moves upward like this. But since it is being pushed downward, we must label our points as so. And right here, we have one complete rotation. And since this question originally states for us to calculate 2 cycles of the graph, we must do that as so. And right here, we have completed the graph. So you could see that this is a sine function, or a sine graph at least, because this function starts at the middle of it. And right here we have 2 complete rotations. Now, we must go back and calculate the equation of the function. And so, we will be doing a sine function. And the basic sine function is this right here. Okay, and so we will begin by calculating the k value. And so the k value is calculated, or just is given to us at least, because the k value is the equation of the axis. And the equation of the axis is the halfway point of the graph. So we can see here that this dotted line here is the equation of axis of our function. And it begins at 1.5 meters. So right here we have our k value. Next, we'll be finding our a value. So the a value is the amplitude of the function. So the amplitude is the distance between the max and the minimum height from the axis. So this dotted line right here. And so we can calculate the amplitude by doing just the maximum height minus the equation of the axis. And so this will be 2.75 minus 1.5. And then this will give us 1.25. And there we go. We already have 2 of what we need. And now the final one that we need to calculate is the b value. So the b value can be written out as 2 pi divided by the period. All right. And so since our period here is 2.854 meters, we will put it into radians form. And all the way at the back that I showed you, that our height can also be written as 5 pi over 2. And so we will use that to calculate our b value. So our b value will be 2 pi divided by 5 pi over 2. And what this gives us is b equals 4 over 5. And there we go. So right here, we have all of the things necessary in order to find our equation. And now, all we need left is the h value. And since the h, where we will be starting our equation, is all the way at the start of the function, there is no h value because the h value represents the phase shift. And the phase shift is where the function starts off. So if we started off our function right here, it would have a phase shift of 3.92, and so on and so on. But since our function starts right here, we don't have a phase shift, so it's just 0. Okay, and so we will write out our equation right here. Okay, and so this is the base value of our function. But there is one key thing. The a value here is positive. So, but as we are shown here, a positive sine function represents the shape of this. It starts in the middle, and it increases higher, and then low, and then back to high. Since our function here begins at the middle and goes downward instead of going upward, as we see in our function here, that means that this is a negative sine function. And so to redraw this, we will have negative 1.25 sine 4 over 5x plus 1.5. So to also redraw this, we have h of x equals negative 1.25 sine 4 over 5x plus 1.5. And now we can see that h of x represents the total distance of the graph moved. Okay, and we have finished our question. All right, and so where would you use this in real life? So where you'd use this in real life is if you were to want to find the height of either a windmill, a Ferris wheel, phase of the moon, because all of those exhibit periodic behavior. And we can use this relationship to separate equations to calculate the variables of the height or whatever you're looking to calculate. All right, and that is my instructional video. Thank you for watching.